Welcome to the next objective, which is to create and configure VNet peering. In the last video, we saw an example of VNet to VNet connectivity. Here we had two different virtual networks, and then we had deployed a virtual private network gateway in each of the virtual networks, and then we had connected these two gateways, which ultimately connected the virtual network. As you can see, the disadvantage of VNet to VNet connectivity is that you need to create a gateway and you need to deploy it within a gateway subnet within your virtual network. So creating a gateway means that creating two virtual machines underneath, and this means more cost. A better alternative that Azure provides is virtual network peering, which does not require you to create any VNet gateway. You can connect two different virtual networks to each other with virtual network peering. These virtual networks can be in the same region or different regions, known as global VNet peering. Once the virtual networks are peered, resources in both the virtual networks are able to communicate with each other with the same latency and bandwidth as if the resources were in the same virtual network. Let's talk about the benefits of virtual network peering. Your network traffic between peered virtual networks is kept private. Traffic between the virtual network is kept on the Microsoft backbone network rather than on the internet, and there is no need for any public internet or gateway or any kind of encryption for communication between the resources in the virtual network. With peering, you can communicate and transfer the data across different subscriptions and across different deployment models and across different regions. And no downtime to resources in either virtual network when creating the peering or after the peering is created. So let's look at a demo. Peering two virtual networks is very simple. First, go into the first virtual network and there is an option called peering under settings. So go into peerings and add. Give the name of the peering and select the virtual network which is present in the VNet resource group. So I'm going to connect it to VNet 2. And if you wish to allow the traffic that has originated from this virtual network peers into this virtual network, then you can select this option. And note that even if you can create a peering between the virtual network, you can still have a gateway. So for example, after this virtual networks are peered, you would like to connect any of the virtual network to an on-premises network, then there is no need for you to deploy two different gateways in two different virtual networks. You can deploy virtual network gateway in only one of the network and the other peered network can use the same gateway. So for example, if I have created a virtual network gateway in the peer virtual network, then that gateway will become a remote gateway for this virtual network. So if you go to the link, it says that if you use remote gateway, then you can use the network gateway that is present in the peered network, or if you would like to have the peered network to use the gateway that is deployed in this network, then you need to allow this option, which is allow gateway transit, which means that the other network can use this gateway present in this virtual network as a remote gateway. So I will leave all these options default and create. The peering status is initiated. So let me go to the resource group and go into the other virtual network and do the same peering operation. So the peering status is connected. So let me check for the virtual network 1. And for this as well, the peering status is connected. So virtual network peering is not fully established until the peering status for both the virtual network is connected. So now let's go and deploy a virtual machine in each of the two different virtual networks so that we can try communicating between them. I have already created two different VMs, so let me take remote of the first VM. So I am in VM1 and let's use ping command to communicate with the VM2 from this VM. Ping uses the Internet Control Message Protocol or the ICMP protocol, which is denied through the Windows Firewall by default. So first, let's enable ICMP through the Windows Firewall so that we can ping the VM2 from this VM. Though ping is used to communicate between VMs in this video, allowing ICMP through the Windows Firewall for production deployments is not recommended. So having said that, let's go and open a PowerShell window. Use the command new net firewall rule and note that the ICMP is enabled through the Windows Firewall. So since we have enabled ping on this VM, let me log into the VM2 and ping the VM1 from the VM2. So I am in VM2. So let me open the PowerShell here. And let me ping VM1, and for that we need to know the private IP address of VM1. So let me go to the test VM1 and under networking, you will see the private IP address. So let me grab that and let me run the command ping. You note that I am getting the reply from the VM1. So this indicates that both the networks are paired and VM from one of the virtual network is able to contact the VM from the second virtual network. In this video, we have paired two different virtual networks and we have tried to ping one VM from the other VM after the pairing. Hello everyone. In this video, we will talk about configuring high availability for your virtual machines, but this time using availability zones. Availability zones, an alternative to availability sets, expand the level of control that you have to maintain the availability of the applications and data on your VM, and it protects your applications and data from data center level failures. An availability zone is a physically separate zone within an Azure region. There are 3 availability zones per supported Azure region to ensure resiliency. And note that not all Azure regions have support for availability zones. Each availability zones is made up of one or more data centers and is equipped with a distinct power source, network and cooling, and is logically separated from the other availability zones within the Azure region. But note that even though they are logically separated, they still have network connections between the availability zones. With availability zones, you can architect your solutions to replicate your VMs across the zones, and you can protect your apps and data from the loss of a single data center. If one zone is compromised, the replicated data and apps are instantly available in another zone. So compare this with the availability set, where the fault domain and update domains only deal within a particular data center, but availability zones goes beyond a single data center and provide resiliency across an entire region. The physical separation of availability zones within a region protects your applications from data center level failures. And zone redundant services replicate your applications and data across availability zones to protect from single points of failure. We have already seen zone redundant applications in storage account. And with availability zones, Azure offers industry best SLA of 99.99% of VM uptime. So that's less than an hour of downtime in an entire year. Note that the availability zone in an Azure region is a combination of a fault domain and an update domain. For example, if you create 3 or more VMs across 3 different zones in an Azure region, your VMs are effectively distributed across the fault domains and the update domains. So the Azure platform recognizes the fact that you are deploying the VMs into an availability zone and make sure to deploy your VMs across different update domains so that the VMs are not affected at platform level updates. So these are some of the regions where availability zones are supported right now. And let's talk about creating a Windows virtual machine in an availability zone or creating a zoned Windows virtual machine. So creation of a zoned Windows virtual machine is very simple. Just go through the normal process of creating a virtual machine, and I will name this VM a zoned VM. And let me put that into a new resource group because I have exhausted my set of resource groups. So let me say this zoned resource group, and the availability zone is supported in the central US location. So I will not change the location. In availability options, you can go to availability zone, and here you need to specify in which of the availability zone that you would like to deploy your virtual machine. So what you would do is you would have something kind of an ARM template or Azure Resource Manager template and deploy your virtual machines iteratively into each of these availability zones. Before that, let me also show you that availability zone is not available in all regions. So if you select East Asia, you will note that availability zone is grayed out and you cannot select any availability zone. So it is only supported in few locations. So you can have any availability zone here. I will just make sure that I have the inbound port HTTP, HTTPS and RDP. And let me also make sure that I have managed disk because your availability zone requires managed disk. Note that since we had selected availability zone as my availability option, unmanaged disk option is grayed out. I will also make sure that I am having the public IP address created, and I will leave all other details default and create. Once created, you can navigate to the virtual machine and check that the virtual machine is indeed placed in the availability zone 1. So when you create a virtual machine and place it in an availability zone, automatically the disk as well is placed in the same availability zone. Here you see that the OS disk is placed in the same availability zone 1. And even the IP address is placed in the same availability zone 1. In this video, you have learned how to configure I availability for your virtual machines using availability zones. Hello everyone. In this video, we will cover defining the deployment slots, rolling back deployments, and implementing pre and post deployment actions. So before looking at each of these in action, I will cover a little theory about deployment slots. When you create an Azure App Service app and deploy your code, the code lives in a default slot or a production slot. Deployment slot is one of the cool features of Azure App Service where it allows you to deploy your app in different slots in the same app. They are live apps and have their own host names. For example, for your application, you can create different slots like development, test, or staging slot. With deployment slots, you can deploy your app first in a staging environment, and you can validate app changes in the staging environment before swapping it with your production slot. If you need to use the deployment slots feature, you need to run the app in the standard or the premium app service plan tier. Let's look at some of the benefits of using deployment slots. With deployment slots, you get to validate your application changes in a staging deployment slot before swapping it with the production slot. After deploying it to a staging slot, you can test the application and its performance. If the application goes down as a result of deployment, not a problem because only the staging slot is down and the real users using the production site are not impacted. After a swap to production, the slot with the previously staged app now has the previous production app. If the changes swapped into production are not working as you expected, you can perform the same swap immediately to get your previous known good site back. Let's talk about the settings that are swapped when you perform a swap operation. When you do a swap, the general settings like your framework version or the 32-bit or the 62-bit information are swapped. And in addition to that, app settings and connection strings are also swapped, but they can also be configured to stick to a slot. In addition to these settings, your monitoring and diagnostic setting of the app are also swapped. Let's talk about the settings that are not swapped. The settings that are custom to an application like your publishing endpoints, the custom domain names, your SSL certificates are not swapped. In addition to that, the scale settings and the web job schedulers are some of the information that are not swapped between two slots when you perform a swap operation. So with some theory in background, let's go back to demo to look at how to implement the three objectives. In Azure, I have already created an app service and an app service plan. So let me go into app service to create a deployment slot. To create the deployment slot, on the left panel under deployment section, you will see an option called deployment slot. So let me go into that. If your app is not already in the standard or premium tier, you will receive a message indicating the supported tiers for enabling deployment slots. So if that's the case, go and scale your app. If you're able to see a window similar to this, then you are ready to create a deployment slot. So to create a deployment slot, just say add a slot and you need to give a name of the slot. Remember that whatever the name you give in over here will be pre-appended to the app URL. So if the app URL is contoso.com, the URL for this deployment slot will become staging-contoso.com. And you can also choose whether you would like to clone the configuration source. And once you have selected the options, you can say OK. It will take some time to create a deployment slot, so let me wait for that. Once the deployment slot is completed, you will get a record over here. And if you go to the dashboard, you will see that a new slot has been created. So first, let me go to my original slot. And there are two ways that you can swap between a staging slot and your production slot. The first option is in your overview page. So in the overview page, you will see an option called swap. And the second option is within your deployment slots page itself, where there is an option to swap. So if you click swap, the contents of the production slot are swapped to the staging slot, which means that whatever contents you add in your staging slot are now in production slot, and whatever contents you had previously in your production slot are in your staging slot now. So I will not do this swap operation now. First, let me go and deploy a sample web application to Azure, and then I will show you how to swap.